Algebra 3, Chapter 1, Section 6, Other Types of Equations. Polynomials. A polynomial equation is of this form. We have a sub n x to the n plus a sub n minus 1 times x to the n minus 1 power plus a sub n minus 2 times x to the n minus 2 power, and so forth until we get to a sub 1 x to the first plus the constant a sub 0, and all of that equal to 0. The degree of the polynomial is the highest power on any x. Polynomials of degree 2 are called quadratics, and we can use our factoring skills to solve some of these higher degree polynomials. We can do that by factoring out common factors, factoring by grouping, or using a quadratic type. So we're going to solve this equation and then check our answer. If you want to, try this on your own, pause the recording, resume the recording to check your answer. Okay, the first thing we notice is that both terms have a common factor. In fact, they have the common factor of x. We also notice that we have a difference of 2 squares. In fact, they actually have a common factor of 4x, which we could have pulled 4x out as well. But we just pull the x out, and now we have 36x squared minus 100 equals 0. 36 is a perfect square, as is 100. So we can factor that into x times 6x minus 10 times 6x plus 10 equals 0. And we are going to have 3 solutions. First of all, we have the x by itself. That equals 0. The 6x minus 10 equals 0, and solving for x, we get 5/3. And then 6x plus 10 equals 0. Solving for x, we get negative 5/3. So our 3 answers are 0, 5/3, and negative 5/3. Okay, now let's try solving this equation and check your solution. If you want to try this on your own, pause the recording, then resume it to check your answer. Okay, we're going to treat this like a difference of 2 squares. So we're going to factor it into x squared plus 9 times x squared minus 9 equals 0. From here, we can split up the x squared minus 9 into x plus 3 times x minus 3. So now we have 3 factors. We have x squared plus 9, we'll set that equal to 0. X plus 3, we'll set that equal to 0. And x minus 3, we'll also set that equal to 0. Solving for x in each case, we have plus or minus 3i, negative 3, and 3. Okay, here's another one to try. Use what we've talked about. See if you can solve this on your own. Pause the recording and resume it to check your answer. First, we notice that every term has an x, or really an x squared. So we are going to factor that out. The other thing I noticed, we have the 9 up front, the 16. There's a really good chance that this would be a perfect square trinomial. How do I know it is? Well, take the square root of the first and last term. The square root of 9 is 3 and the square root of 16 is 4. Multiply them together and then multiply that by 2. If you get the coefficient of the middle term, then you know you have a perfect square trinomial. So 3 times 4 is 12, times 2 is 24. So this will factor as a perfect square. So first we pull out the x squared, and then we factor our perfect square into 3x minus 4 times 3x minus 4. And we say that x squared equals 0, so x is 0. 3x minus 4 equals 0, so x is 4/3. So we actually only have 2 different solutions for this, 0 and 4/3. Okay, here's another one to try. Before you give this an attempt, let me give you a hint. Even though we have x to the 4th and x squared, we're actually going to treat this like it's quadratic. And see if that gives you a starting place. Pause the recording, give it a try, and resume the recording to check your answer. So you can see what we've done here. Instead of 4x squared, we have 4x to the 4th. If it had been 4x squared, we would have made it 4x and x. But instead, since it's 4x to the 4th power, we use 4x squared and x squared. But we're really kind of treating it like we're factoring a quadratic. The numbers that are going to give us 16 are negative 1 and negative 16. We're using those because when we do the outside and the inside and combine them, we end up with negative 65x squared. Both of these factors are differences of two squares, so we're going to split those up into 2x plus 1 times 2x minus 1 and x plus 4 times x minus 4. We're going to set each of these four factors equal to 0, and it's going to give us negative 1/2, 1/2, negative 4, and 4. And now we're going to look at a few other types of equations. We've done polynomials. Now we're going to look at three other types, and the first is radical equations. Radical equations are equations that involve a root. Specifically, the x is under a root. In order to do this, you need to isolate the radical on one side, or if there's more than one radical, you need to isolate one of them on one side. Then what we're going to do is raise both sides to the power that will eliminate the isolated radical. In other words, if we have a square root, we will square both sides. If we have a cube root, we will cube both sides. If you have a fourth root, you will raise both sides to the fourth power, and so on. We will then simplify and solve. Now, if you start with more than one radical, you're going to probably need to repeat this process, so you need to be patient. The next type of equation we're going to look at is going to be rational equation. Now, we've already done these, but they're coming back up here. What we're going to do is we're going to multiply every term in the equation by the least common denominator of all the fractions. Remember, the advantage to this is it eliminates the denominators and makes it much easier to solve, and then we'll solve it. Do watch out for extraneous solutions, though. Remember, those are answers that you get for x that will cause you to have a zero denominator. You do need to eliminate those from your answers. And then finally, we're going to look at absolute value equations. When we have absolute value equations, we solve them twice. We solve them just like you see them without the absolute values. And then we solve them again, but we put a negative on the number on the right-hand side of the equation. And you will get, for most of your absolute value equations, you will get two answers. And again, be sure to check for extraneous solutions in all three of these types of equations. So here we have a radical equation. Why don't you give this a try and then resume the recording to check your answer. All right, first thing we want to do is add the 12 to both sides. In other words, we want to isolate the radical. So get the 12 away from it. Then what we're going to do is we're going to square both sides. That eliminates the square root on the left, and 12 squared is 144. We then divide by 3, and we get 48 for our answer. Now try this radical equation. Pause the recording, give it a try, and resume the recording to check your answer. This one's a little more complicated. What we have to do is isolate one of the radicals. So I'm going to get the square root of x plus 5 by itself by subtracting the square root of x minus 5 from both sides. Then I have to square it. Now here's where it gets a little weird. When we square the left-hand side, it cancels the square root as usual. But the right-hand side, we have to use FOIL. We have to do 10 minus the square root of x minus 5 times 10 minus the square root of x minus 5. Foiling it out gives us 100, 10 times 10. Then we have 10 times the negative square root of x minus 5 plus 10 times negative square root of x minus 5, which gives us negative 20 square root of x minus 5. And then we have plus x minus 5. That's what you get when you square the square root of x minus 5. So do this very carefully. Now we're going to kind of do the same thing all over again. We need to get that radical by itself. So we're going to combine like terms, and we're going to start moving things away from it. So we can combine the 100 and the minus 5, and we can get 95, and then subtract it from both sides. And also notice we have an x on both sides, so we can subtract x from both sides, and it goes away. So now we have negative 90 equals negative 20 square root of x minus 5. Then what we did in this particular problem is we divided both sides by 10, by negative 10, and got 9 equals 2 square root of x minus 5, and then squared both sides. Now, you could have divided both sides by -20. You would have ended up with 9/2. And then square both sides, you would have 81/4. And then you would add the 5 to that. And that's a perfectly fine way to do this. The book took a little different approach. Like I said, they divided by -10 and got 9 equals 2 times the square root of x minus 5. They squared both sides, so you get 81 equals 4 times x minus 5, because you have to square the 2 also. Then they distributed, so you have 81 equals 4x minus 20, added the 20, and then divided by 4. The advantage to doing it this way is you don't have to worry about a fraction till the very end of the problem, but it is possible to do it the other way as well. Okay, let's try this equation. Now, this is going to be similar to what we did. So give it a try on your own and pause the recording to do that and resume it to check your answer. So what we have here is we have the square root of x minus 20 equals 10 minus the square root of x. Now you could have subtracted the square root of x minus 20 from both sides, but if you do a little thinking ahead of time, you'll realize that you're going to have to square, you're going to have to use FOIL on whatever you put over on the right, and so by moving the square root of x, we actually are making our work a lot easier. So the next thing we're going to do is we're going to square both sides. We get x minus 20 equals 10 minus square root of x squared, and we're going to use FOIL to multiply that. So we get 100 minus 10 square root of x minus 10 square root of x plus x. And we're going to combine like terms. X minus 20 equals 100 minus 20 square root of x plus x. And now we're going to get the radical isolated all over again. We can subtract the x from both sides. We can subtract the 100 from both sides. Then we'll be dividing by -20. So we subtracted the x, we subtracted the 100, we divided by -20, and then we square. And our final answer is 36. This one's a little strange. It is a radical because we have the fractional power. What you need to remember is the top number tells you what power you're raising it to. In other words, you're going to take x minus 5 and you're going to cube it. The bottom number tells you you're going to take the square root of that. So remember, the top number tells you what power to raise it to. The bottom tells you what root you're taking. See if you remember how to do these. There's actually a kind of a shortcut to it. Try the problem, pause the recording, resume the recording to check your answer. Okay, so what we want to do is we want to eliminate the 3/2 power. Well, remember, when you raise a power to a power, you multiply the powers together. So if we square both sides, we're going to have to multiply 3/2 times 2, which eliminates the denominator and gives us x minus 5 to the third. And that equals 8 squared, or 64. Then we can take the cube root to get rid of the third power. So we have x minus 5 equals the cube root of 64. Well, the cube root of 64 is 4. Add 5 to both sides. 5 plus 4 is 9. Now we have a rational equation. Remember, you want to multiply everything by the common denominator. Pause the recording, give this a try, and resume the recording to check your answer. So our least common denominator is really the two denominators multiplied together. And we multiply every single thing by the common denominator. Notice that what we're going to be able to do in the first fraction is cancel the x plus 1s. In the second fraction, we'll cancel x plus 2. Don't forget the 1 has to get multiplied by the common denominator as well. When we multiply everything out and cancel, we get this. Now we're going to combine some like terms, and we're going to make our quadratic equation. We're going to put it in standard form, which means make sure it equals 0. So we did that there. And you really can't factor this. There are no two numbers that will give you -9 by multiplication that will give you -4 by addition. So you need to either complete the square or use the quadratic formula. And here I used the quadratic formula. And notice that I made sure to simplify my square root. Had the square root of 52, which becomes 2 square root of 13. You can then factor out a 2 and cancel, and your answer is 2 plus or minus the square root of 13. Now an absolute value equation. Remember, you want to solve these twice. These really aren't difficult if you can remember, solve them twice. Pause the recording, give it a try, and then resume the recording to check your answer. Okay, these are the two ways we need to write the equation. 2x minus 5 equals 11, which is exactly the problem as it is without the absolute value bars. And then we also write 2x minus 5 equals negative 11. The reason for that is that the absolute value of 11 gives you 11, but the absolute value of negative 11 also gives you 11. So we have to account for both those possibilities. That's the hard part. Now we're just going to do a little algebra to solve. We're going to add 5 to each side, and then we're going to divide by 2, and we get 8, and we get negative 3. Now a word problem. We have a deposit of $3,000 in a savings account, and it reaches a balance of $4,042.05 after 6 years. The interest on the account is compounded quarterly. What is the annual interest rate of the account? Now I've given you the formula here. The formula is A equals P times 1 plus R over N to the NT. Just to give you some information, A is the amount that you have at the end of the time period. P is your principal, or how much you started with. R is your rate, which is expressed as a percent. N is how many times it's compounded. In this case, it's compounded quarterly, which means 4 times a year. And T is time, which for this problem is 6 years. Now, if you want to go ahead and put all that information together and give this problem a try, pause the recording to do that, and then resume the recording to check your answer. Okay, so here are all our numbers spelled out. We know A, we know P, we know N, and we know T. We don't know R. So R is going to be our variable. We put everything in place. And you can see that what we did is we simplified the 4 times 6 to 24. Then we divided both sides by 3,000. That gives us the 1.34735. Then we take the 24th root. Fortunately, our calculators can handle that, of both sides. Then we're going to subtract 1 and finally multiply by 4. And what they did here is they kind of put that all as an expression so they could put it all at once into the calculator, which gives you the most accurate answer. The result is 0.05, but remember, this is a percent, so it will be 5%.